Hi, everyone. Thanks for joining us for this event on rapid transfer ports. The goal of today's discussion is to expand everyone's understanding of the various ways that rapid transfer ports can support your aseptic processing needs. During our time together, we'll cover the pulse of aseptic processing, rapid transfer port design, beta assembly options, and single-use capabilities. My name is Kyle Baer. I'm a sales account executive with Central Research Labs, and I'm happy that you're all willing to spend the next 30 minutes with me. I'll be posting my contact information at the end of the webinar. That way we can connect one-on-one if I haven't completely scared you off at that point. For 75 years, CRL has been a trusted supplier of remote handling solutions. Our innovative technologies provide reliable and safe protection for operators working with hazardous and sterile materials in the life sciences and nuclear industries across the world. We offer high quality products and exceptional technical expertise and support. So today, more than ever, compounds and therapies are being developed in aseptic environments. And this trend doesn't appear to be slowing down anytime soon. As a result, a lot of people are stepping up to support aseptic processing. Regulatory entities and guidelines like EMA, FDA, USP, and Annex 1, just to name a few, have already or will be revising recommendations to help provide more clarity around how to best manufacture sterile medicinal products. Containment system manufacturers are creating units and systems that are far more advanced than ever. Several other manufacturers and engineering companies have developed or improved upon cutting-edge technology for the aseptic suite too. One of those technologies is rapid transfer ports, also known as RTPs. RTPs have been used for years in the nuclear and life sciences industries and are used in conjunction with containment systems like isolators, RABs, or hot cells. While they've evolved over the years, at its core, RTPs still consist of two key components. An alpha port that's installed on the isolator wall, and a beta assembly, which is mobile and ultimately carries the desired items into and out of the isolator. The beta assembly mates and docks to the alpha port. At this point, the beta assembly essentially becomes an extension of the isolator so that containment is not breached when the alpha doors open. Companies like Sartorius, Getting A, ATEC, and CRL, just to name a few, manufacture these types of ports. As with anything, RTPs have strengths and weaknesses. Let's examine some of these before we dive into their different configurations and applications. The sizes, materials, and configurations of RTPs provide significant versatility. Alpha ports are typically composed of stainless steel and/or polypropylene, making them simple to clean. The double door and interlock design make it possible for containment to be maintained when the alpha port is and is not in use. And the complete engineered alpha and beta system allow for a fast and repeatable transfer process. So an aspect of RTPs that's attracted a fair amount of attention is the area of concern or ring of concern. This is where the alpha door and the beta flange, which is connected to the beta assembly, meet. Take note of the call out on the slide. There's potential for this area to become contaminated after repeated use with insufficient cleaning. So to take it a step further, if items or tools are placed in a beta assembly, then docked to the alpha port and brought into the isolator, there is a chance that those items could graze the area of concern and bring contamination into the isolator. While appropriate attention should be brought to this area, it does not need to be a concern if properly controlled. The area of concern can be addressed by any number of ways outlined here. Covering the sealing surfaces with contained transfer funnels or sleeves. The use of proper standard operating procedures involving periodic cleaning. Or heat sterilizing the sealing surfaces for sterile transfer with specifically designed alpha ports. More to come on this later in the discussion. Another consideration to keep in mind regarding RTPs is that larger beta assemblies can be heavy. In this situation, you may want to consider ways to support your beta assembly to assist the operator. And lastly, prices and cleaning requirements will differ based upon the materials and applications. So now let's move a little deeper into the designs and applications of RTPs. First, we'll start with the alpha port. These ports come in various configurations depending on the application and the manufacturer. In general, you can find early generation RTP alpha ports like the one displayed on this slide. These RTPs have evolved into newer versions, like this Clean Rapid Transfer port by CRL. The CRTP, or Clean Rapid Transfer port, has smooth surfaces, making them easy to clean and gentle on gloves. The handle also requires minimal rotation to break the seal of the beta component. As briefly mentioned earlier, CRL RTPs and some other manufacturers feature mechanical interlocks that prevent improper operation of the transfer port, which can compromise the containment and sterility of the barrier system or isolator. The interlocks are incorporated into the alpha flange and interface with the alpha port door handle to prevent the door from being opened when a beta assembly has not been docked. The interlocks also keep the beta assembly from being removed from the alpha port when the alpha port door is open. The sterilizable rapid transfer port, or SRTP by CRL, is another version of an RTP that was specifically designed to transfer materials like stoppers or vials into an aseptic containment system. The SRTP has many of the features discussed earlier, like mechanical interlocks, but also utilizes an electric heater in the alpha flange at the intersection of the seals. This area is heated to 190 degrees Celsius and held for a predetermined time after the alpha and beta are docked. Independent tests have shown a 6-log microbial reduction when the heat cycle is used. RTPs come in several sizes. The standard sizes that you'll typically find them in are 105, 190, 270, and 350 millimeters. The 190 size is the most widely used size and offers a good amount of flexibility in terms of the material or items being transferred. 105 is more commonly used for fluid transfers, while 270 and 350 are used more often to move larger items like tools, waste, or equipment. And RTPs can go just about anywhere you want on your containment system. Think about your operator, the items being transferred, where the items need to get inside of the isolator, proximity to glove ports, and the space around your isolator. CRL and some other manufacturers also make RTP flexible mounts for situations where connection alignment is difficult. These make it possible for the alpha flange to rotate to ease the docking process. And this is pictured on the slide on the right-hand side. And if you already have a containment system that doesn't have RTPs, or it has one, but you prefer a different location or a different type, don't worry, you're not stuck. CRL can work with you to add an RTP or modify your existing RTP. So we've covered half of the RTP equation. Now let's move a little further along the Greek alphabet and explore the beta components. You name the process or application, and there's probably a beta assembly for it. And if there isn't, someone will build it. So let's start with one of the more commonly used beta assemblies, those used for solid item transfers. These feature a gas-tight design and are available in all the diameter sizes mentioned earlier, 105 to 350 millimeters. And lengths run anywhere from 4 to 24 inches or 101 to 609 millimeters. And CRL works with organizations on custom configurations. More to come on that in a little bit. This video shows how the beta canister docks to a CRTP. You can see how this process can help make transferring items like supplies, tools, or byproducts into or out of an isolator seamless. And because component sterilization is such a common process in the aseptic suite, beta canisters have been developed specifically for autoclaving to make transferring even easier. These autoclavable beta canisters are designed for moist heat sterilization and are available in stainless steel and anodized aluminum. Liquids can also be conveniently transferred with RTPs. CRL engineered a safe, aseptic, and cost-efficient method to do just that. The solution moves liquid from bulk tanks into isolation. The sterile liquid transfer port, or SLTP, uses three components to perform this transfer: an SLTP beta flange with steam connections, a steam-in-place docking plate, and a CRTP alpha with liquid transfer door. This video shows what the process looks like. The SLTP beta flange with steam connections are docked to the steam-in-place docking plate for sterilization. Tubing and components needed inside of the isolator can be sterilized in an autoclavable beta container and transferred into the isolator. Next, the SLTP beta flange is ready to be docked to the CRTP alpha with liquid transfer door as seen here. Now, isolator side connections can be made and filling can begin. Once filling is complete, isolator side connections can be disconnected and the beta assembly can be undocked. So there are several ways of bringing liquid into containment. This is a great way of doing it while utilizing an RTP port. RTP technology can be adapted for different needs. Look no further than this waste drum transfer system to see a good example of this. At the core of the system, you have an RTP door mounted to the bottom of a containment system so that large amounts of sensitive waste can be effortlessly transferred out. I emphasize effortless because nearly every step in the process is assisted or automated. We're talking about docking a 30 or 55-gallon drum or drum liner, so you can see why the system was engineered this way. The cover of the waste drum or waste drum liner is engineered to mate to the bottom of the port door, just like an alpha and beta component of an RTP. This allows the waste drum to dock to the isolator once it's raised. One button provides the rotation for docking, and another button lifts and opens the port door inside of the containment system. This type of system may not be applicable to the type of work happening at your facility, but it demonstrates the full extent of how RTP technology can be adapted for different needs. There will likely be situations where a standard RTP assembly just won't cut it for your application. Fortunately, customization is usually an option, and CRL is no stranger to that. You may need inset alpha doors. This makes it easy to dock beta assemblies of different sizes to the same alpha port. So on the left, you can see a 105 door set inside of a 270 door. Maybe you no longer need that large alpha port that's on your isolator. An alpha conversion could be the answer. An RTP can be converted to a different size without using up precious isolator real estate. And RTPs can be designed for auto docking. CRL and other manufacturers have developed RTPs that can dock with the push of a button for applications where you want to make your RTP as effortless as possible. And this is pictured in the middle. And at some point, you may want beta assemblies for alpha ports built by other manufacturers. We know how frustrating it can be when your equipment needs are limited to one supplier. And that's why CRL engineers have developed beta assemblies that are able to dock to other alpha ports. The single-use beta bag that's pictured to the right is a perfect example of that. So far, we've examined the reusable side of rapid transfer ports. Now let's pivot and look at how single-use technology can support your transfer needs. Some of the burdens of sturdy reusable containers become strengths for single-use options. So let's explore a couple of these. Reusable vessels can be cleaned and docked endlessly throughout an aseptic processing facility. However, with that comes a risk of cross-contamination. Using a single-use transfer item once and disposing of it reduces that risk significantly. Single-use transfer items can arrive at a facility pre-sterilized or sterilized one time upon arrival. Then they're used and disposed. Because numerous cleaning processes per item are not required nor recommended, cleaning validations and their associated costs are significantly reduced. The price for a stainless steel transfer vessel will vary, and it's a one-time purchase. But it's a four-figure purchase before you even validate it. The purchase process for disposables is ongoing, but it'll cost significantly less than reusable alternatives to get you started. The transfer needs for one campaign may differ from the needs needed for another campaign. Single-use items make it easier to accommodate those changes. And lastly, everything we just discussed can equate to time savings, which will help your product get to market faster. Single-use technology is penetrating nearly every element of aseptic processing. But when looking specifically at the RTP category, the core items that you'll find are beta bags, tubing, and connectors. Single-use beta bags can take the place of beta canisters. They're available in many sizes and are typically composed of plastics and/or breathable materials to improve autoclaving. This beta bag by CRL features Tyvek and high-density polyethylene. I'm also excited to share that the engineering team behind this beta bag decided to expand the capability of the flange. One bag type features a flange that docks to CRL ports. A second bag type docks to alpha ports for other manufacturers. This versatility allows customers more flexibility in how and where they'll use the bags. Bags like this make it possible to transfer items like stoppers, vials, tools, products, and others into containment. Or you can transfer byproducts, yields, or waste out of containment. So using single-use beta bags also allows you to take advantage of additional services that can increase efficiency. Pre-sterilization can take some work off of your plate. Here, distributors and suppliers have the capability to sterilize the beta bags and ship them directly to accounts, so they're ready to use. Kitting can make life around an isolator a lot easier too. Kitting is a service that takes pre-sterilization to the next level. With kitting, the beta bags are filled per your request, then sterilized and shipped to the account. Now the bags are ready to be docked so that the requested items can be transferred into the isolator. Common items requested for kitting are stoppers, cleaning products, or labeling supplies. It's really ultimately dependent upon what you want. It's a service that essentially allows accounts to request sterile and transfer-ready items. Single-use tubing and connectors can be used in conjunction with reusable systems like the SLTP system that we looked at earlier. In these situations, they move fluid from bulk tanks into the isolator. They're also being built into beta bags to form fully disposable liquid transfer systems. One bag can house the tubes and connections required for inside the isolator, as well as the lines that will connect outside the isolator. This type of configuration allows for a lot of customization based on application needs. So before we move forward, let's summarize a couple key points that we discussed here today. We started this discussion with how aseptic processing is growing and being supported by isolator technology. RTPs have become an excellent means of transferring into and out of your isolator. We examined the design and beta assembly options associated with RTPs. And we rounded things out with how single-use technology is being integrated into RTPs. I hope that you're able to walk away with a greater appreciation for all the ways that RTPs can support your work.